Good morning, children. So we are doing exercise 12.2 and now we will do question number 14.1. So here question says if x be real, prove that the value of this cannot lie between 5 and 9. Okay. So how to do this type of question? So for this what we will do is here we will put this whole thing as y. Okay. So we'll write let x square minus 34x minus 71 upon x square minus 2x minus 7 is equal to y. Okay. Now you do cross multiplication. So you get x square minus 34x minus 71 is equal to x square y minus 2xy minus 7y. Now next, bring all the terms which you have on the right hand side to the left hand side. So you get x square minus x square y minus 34x plus 2xy minus 71 plus 7y is equal to 0. Now from these two terms x square is common, so I'll get 1 minus y x square, and here you can see x is common. Okay, so we will get 34 minus 2y and here x, and this can be written as simply like this 71 minus this equal to 0. So here what do we observe? We observe that this is a quadratic equation in x. Okay, so I put this as equation 1. Clearly equation 1 is a quadratic equation in x. Okay, where your a is equal to 1 minus y, your b is equal to minus 34 minus 2y, and your c is equal to minus 71 minus 7y. Okay, so this is a quadratic equation in x where a is this, b is this, c is this, and also x belongs to real number. Okay, so if you have a quadratic equation where x is from real number, then in that case discriminant will be either 0 or greater than 0. Okay, so as x belongs to R, then d will be greater than equal to 0. Okay, this implies b square minus 4ac will be greater than equal to 0. So we will substitute the values. So for b, then minus 4, and here a is 1 minus y and c is this. Done. Now here you can see 34 and here 2. 2 is common, so I get minus 2, here 17 minus y and whole square, and here 1 minus y minus 71 plus 7y is greater than equal to 0. Now this square is for this minus 2 as well as for this 17 minus y. So you get 4 and here 17 minus y whole square, here 4, and you can open the bracket, so 1 will multiply to this, so you'll get minus 71 plus 7y, and this minus y will multiply, so you get plus 71y minus 7y square greater than equal to 0. And you can see in both the terms 4 is common, so you can divide throughout by 4. Since we are dividing by a positive number, direction will not change. Okay, so we get 17 minus y whole square minus 4, and here you will get minus 7y square plus 78y minus 71 greater than equal to 0. Sorry, this 4 is not there. Now next, a minus b whole square formula. So we'll get 289 minus 34y plus y square, and here open the bracket, so you'll get plus 7y square minus 78y plus 71 greater than equal to 0. So y square plus 7y square, you get 8y square, here 34y, and here minus 78y, so you have to add, so you will get 112y, and this 289 plus 71, so here 10 360. Now you will observe that 812 and 360, these are divisible by 8, so you get y square minus, when you divide this 112 by 8, okay, so you will get 14, and here you will get 45. So we got, now here what do we observe, that on the left hand side we have a quadratic equation in y, so we have to factorize this. So here we can write y square minus 9y minus 5y plus 45 greater than equal to 0. Then we get y minus 9, here 5, y minus 9 greater than equal to 0. So we got y minus 5 and y minus 9 over here. So here you can see that here also minus, here also minus, so good for us. Now we will draw the number line. This is the number line. Now this is 5 and this is 9. So because of 5 and 9 we are getting 3 intervals. Okay. Zero will be in this interval. Okay. This is plus infinity. This is minus infinity. Now we have to substitute. We have to find which interval will satisfy this. So better we check with y equal to 0. So on the left, if you put y equal to 0, then you'll get minus 5 into minus 9, which will be 45 greater than equal to 0. Yes. So that means this interval is coming positive. So this will be negative and this will be positive. So you can see that only minus infinity to 5 and 9 to infinity, only these two intervals are satisfying, and this interval 5 to 9 is not satisfying. And you can clearly see that they had asked you to prove that only, that value for this, okay, will not lie between 5 and 9. So here you can see that this y has to be from minus infinity to 5 or 9 to infinity, but not in between 5 and 9. Okay, so you can write therefore y will be less than equal to 5. Why I am writing equal to? Because here 0 is also there. Okay, greater than equal to 0. So or y will be greater than equal to 9. So obviously y is not in between 5 and 9. Okay, so therefore we have proved. So you can write thus. Now we have to write down that expression. So it is x square minus 34 minus 71 upon, sorry, x is there, x square minus 2x minus 7 or plus 7, let me check once, minus 7. Okay, yes, thus here we have to add thus, one second, thus value of this does not lie between, in short I'm writing between, okay, between 5 and 9. Okay, so this proof is done. Okay, the next questions are going to be your homework. Okay, question 14.2, if x is real, show that the value of this cannot lie between this. So you have to do same as what we have done right now. Okay, same as the previous question. Same way you will do this also. Show that this cannot lie between minus 7 and 1. So these two are your homework. Okay. Next question is question number 20. This will be the last question for this chapter. So here it says, if x be real, find the maximum and minimum values of this. Okay. So for this, what we'll do, we will put this as equal to y. So let this given equal to y, and then cross multiplication. Okay, cross multiplication you have to do, and after cross multiplication you will get this x square y plus 2xy plus 3y. Done. And then everything that you have on the right should be taken to the left. Okay, and you have to get a quadratic equation in x. That means you should write in this form. Okay, like here you can see this is like your a, this is like your b, this is like your c. Okay, so you got a quadratic equation in x. Clear? Then once you got this, as we know that x is real, okay, this is a quadratic equation in x and this x is real, and you know that for a quadratic equation, if x is real, that means discriminant will be greater than equal to 0. Okay, so as x is real, then discriminant will be greater than equal to 0. So here discriminant is b square minus 4ac. So here your a is this, b is this, and c is this. Okay, so this is a, this is b, this is c. So you have to substitute the values. So we get 2 times 7 minus y. okay, whole square minus 4 into this 1 minus y into 9 minus 3y greater than equal to 0. Now you have to simplify it. So after simplifying, okay, we will get this. So here you can see that this square is for 2 as well as for this. So we got 4, and here 7 minus y, that means a minus b whole square formula, we got this. Clear? And then 4 was left outside and this 2 were multiplied and we got this. Okay. And in the next step, this 4 and this 4 was common. Okay, so we divided throughout by 4. So we got rid of this. Clear? And here we got y square minus 14y plus 49, and here 3y square, here minus 3y and 9y becomes minus 12y plus 9 greater than equal to 0. Done. Now open the bracket, simplify it further, and you get minus 2y square minus 2y plus 40 greater than equal to 0. Now I am taking minus 2 common. Okay, so I got minus 2, and here y square plus y minus 20 greater than equal to 0. Done. Now I want to remove this minus 2. So this is a negative number. So I will divide by minus 2 throughout. But since I am dividing by a negative number, so this direction will change. Can you see? This direction has changed. Clear? So you got y square plus y minus 20 less than equal to 0. So you got a quadratic equation in y. Okay. Now you have to do middle term splitting. So here 1 and here minus 20. So think of two numbers whose product is minus 20 and sum is plus 1. So 5 and minus 4. Okay. So you got y square plus 5y minus 4y minus 20 less than equal to 0. Then y is common. So you got y into here in bracket y plus 5 minus 4 y plus 5. Then you got y minus 4 y plus 5. But here you can see plus sign is there. So in the next step I will write y minus minus 5 and here y minus 4. Okay. Then we'll draw the number line. Okay. And then we'll plot minus 5 and 4 first. And because of this we are getting 3 intervals. Okay. And we will check which interval is satisfying. So first we'll check for y equal to 0. So if you put y equal to 0, then you'll get 5 into minus 4. So minus 20, which is less than 0. Okay. So and that 0 is in this interval. Yes. So this interval will give you negative. So minus, and then the other intervals are going to be filled alternatively. Okay. So you got minus, plus, and here plus. So you can see that only this interval is satisfying this one. Okay. So y, minimum value for y is minus 5 and maximum value for y is 4. Okay. Because equal to sign is involved over here. So minimum value for y is minus 5 and maximum is 4. So in next step we can write y is between minus 5 and 4. And thus maximum value for this will be 4, because this we had considered to be y. And here what do we see? That maximum value for y is 4. That's why maximum value for this will be 4 and minimum value for this one is minus 5. Okay. And this is done. So this was the last question from this chapter, and with this chapter gets over. Okay.